So Unit 5, we're going to start off by reviewing X-Intercept and Y-Intercept. Now in Unit 5, we're going to talk about parabolas a lot. So I've drawn a parabola on the board. Our review today of X-Intercept and Y-Intercept, though, we are going to use equations that make lines. Okay? But look at the parabola. How many times did it cross the x-axis?
Twice. Two.
Twice. Okay? This is the x-axis. How many times did it cross it? Twice. There and there. Okay? How many times did it cross the y-axis? Once. Okay, right down here. That is the case for all parabolas. We'll cross the x-axis twice and the y-axis once. Okay? With a line, we started them last year. How many times does a line cross the y-axis? Once. How many times does the line cross the x-axis? Once. Okay? So they're a little bit different. All right? So, y-intercept. Which of these circles is the y-intercept? The green ones. The green circle is our y-intercept. Okay? Our y-intercept, what is that point? What's the y-intercept? How do I find the y-intercept? Doug? Okay, when y equals 0. So where on this graph does y equal 0? No. Well, the origin's one spot. But where does this graph? Where does y equal 0? When the graph crosses what? The y-axis. Okay? The y-intercept is the point where the graph crosses the y-axis. The point where the graph crosses the y-axis. Since it's the point where the graph crosses the y-axis, what is our y value there? No, that's a trick question. Okay. Our y value can be anything, right? Because this is our y-axis, isn't it? Any y value is possible, right? What's our x got to be here? 0. Our x has to be 0. This y-axis, I know it's called the y-axis, but it's also the line that represents all x values being 0. Okay. So at this point, x equals 0. X equals 0 at that point. Okay, right here, this is our y-axis, or sorry, this is our y-intercept. At that point, x equals 0. Right? Okay, so x equals 0 right there. If x equals 0, that means the general form for this point is going to be 0, comma what? Y. Where y can be any possible number. Okay? So general form is going to be 0, comma y, where y is any possible number. Now, every line on the graph comes from what? If I'm going to use my calculator, I'm going to make a line on the graph. What do I have to do? Put in an equation, right? So every line on the graph comes from an equation. Okay? If I'm going to find this y-intercept right here, how can I find that specifically? How can I find the exact value of that y-intercept? Some of you are thinking, I can use my trace function on my calculator, right? I can use the trace, put the little cursor right there, right? Is that exact? No, what is that? It's an estimate, it's an approximation, right? How can I find the exact value of this? I need to use my equation and do what? Not sub for y. We're going to get y by itself eventually. But what should I sub in for? X. Davian, what should I put in for x? 0. Good. If I plug 0 into my equation that represents this line, I will find that value of my y-intercept. Okay, we'll practice that in a little bit. All right. So to find, and for short, instead of writing out y-intercept, I write y-int. To find y-int, plug in 0 for which one? X. And solve for y. So to find the y-intercept, plug in 0 for x and solve for y. Are there any questions about the y-intercept?
Yeah.
What's the question, Rob?
When you have x equals 0, and you were like, what point does it
Mhm.
equal 0? Like, what point does it equal 0?
What point does it equal 0? When we plug in for x equals 0 in our equation, then we'll get a y value out. Okay? And it'll be 0, comma y. And it'll be a point on this graph. Okay, let's do one for example. Let me do one for example real quick. Okay, let's try this. Negative 4x plus 5 equals y. Okay? So I know, guys, this equation right here, this is not the parabola, right? Because parabolas have to have x squareds. Okay, this would be a line, right? To find our y-intercept, what do we have to do here? Plug in what for x? 0, right? So it's going to be negative 4 times 0 plus 5 equals y. Okay, what's negative 4 times 0? 0, right? So this ends up being what? No. This is 0, right? Right? So we end up with 0 plus 5, which is 5, right? So my y-intercept is going to be the points. My y is 5. What's my x? 0. So the y-intercept then is 0, 5. Okay, does that make sense? Okay. All right, X-intercept. X-intercept. What do you guys think it is? If y-intercept's the point where the graph crosses the y-axis, what do you think X-intercept is? Where it crosses the x-axis, right? This is the point where the graph crosses the x-axis, right? The point where the graph crosses the x-axis. Which circle is it on the graph? Which color, green or blue? Blue. The blue circles on the graph are the x-intercept, right? It's the point on the point where the graph crosses the x-axis. So these are my two blue circles, right? Right? Which value is 0 here? We have two values, x and y, right? Which value is 0 here? The y, right? I can have any possible x value on this line, right? But we always know if I'm on this line, then our y value is 0. Okay. So at the x-intercept, y equals 0, right? So they will always look like x equals 0, where x can be any number. So how do you think we find the x-intercept? Plug in 0 for y and solve for x. So to find the x-intercept, plug in 0 for y and solve for x. Plug in 0 for y and solve for x. You're probably thinking those math teachers don't know what they're doing, right? X-intercept, plug in 0 for y. Y-intercept, plug in 0 for x. Kind of confusing, right? Yeah, it can be a little confusing. We just have to remember that for our y-intercept, it's the line where all the x's equal 0. For our x-intercept, it's the line where all the y's equal 0. I just gotta keep that in mind. All right, kind of switches on us. Okay. All right, so a real quick example like we did for this one. If this was the y-intercept for this problem, right, 0, 5, How do I find the x-intercept? I take this equation and do what? What do I do, Mark? Plug in 0 for y. We take this equation and plug in 0 for y. So, the equation, negative 4x plus 5 equals y. So to find the x-intercept, we plug in 0 for y. So it looks like that. Negative 4x plus 5 equals 0. Dave, are you with me? Okay. What do I do now? Subtract 5. Right? Now we're just turning into an algebra problem, haven't we? Right? Remember, we write it over here so we all can see. So these are going to cancel. We get negative 4x equals negative 5. Now what do I do? Divide by negative 4. Negative 5 divided by negative 4. 1.25. Okay. Yes, Josh.
Why do you have to divide subtract it by 5?
Because we got to move the 5 over here to get the x by itself. Just like solving for x in any algebra problem. Okay? All right. So that means that our x-intercept is going to be 1.5 comma what? 0. Or sorry, 1.25. Sorry. 1.25 comma 0. And now that I have 2 points, what can I do with those 2 points? We could graph them and we can make a what? No. A line. I told you earlier, guys, this was a graph for a line, right? We could plot these 2 points and make a line. I'll show you that. So 0, 5 would be up here. Okay. 1.25, 0 would probably be right there on the axis. So then our line, not very straight, but that's how our line would look. Okay. All right, are there any questions about what we do with x-intercepts or y-intercepts? Any questions? We're going to do some more practice.